Hello friends, welcome to Kishor Premier Academy, one of the most premier institute for GATE, IES and PSU examinations. In this video, we are going to discuss about the material because we are interested in understanding the electronic devices. Electronic devices. These electronic devices are made up of semiconductors. These semiconductors are special type of materials, and these semiconductors have special type of materialistic characteristics. So to understand the behavior of these electronic devices, we need to understand the material characteristics of the semiconductor also. Otherwise, we cannot understand the electronic devices. So let us see what the material is. So material, if we define the materials, then we can say that material is a substance is a substance or a mixture of substance or a mixture of substances that constitutes an object. So material can be a substance and also be a mixture of substance. So this was the definition of materials. Now these materials can be classified depending on different aspects. We can classify the materials depending on the following aspects. So if we see the classification of materials, then we can find that the material can be classified depending on different aspects. So the first classification can be done based on mechanical property. The second classification that can be done of the materials is based on their chemical property. The third classification of the materials can be done based on their electrical properties. In the fourth case, we can classify the materials depending on their thermal properties. And in the fifth one, the materials can also be classified on their optical properties. And the sixth one is material can be classified depending on the structural properties. So all these 6 points define that a material can be classified depending on different aspects of their properties. So our concentration is to understand the electronic devices. And for understanding the electronic devices, we need to understand the classification which is based on the electrical property of the materials. That means we need to understand the classification of the materials depending on their electrical property. The second one we need to understand, that is depending on the structural properties. So these two classification aspect we need to understand if we want to understand the electronic devices. Let us see how the materials can be classified depending on their electrical properties and structural properties. So we can say the classification of materials depending on electrical properties. If we classify the materials depending on the electrical properties, then materials can be classified into three groups. The first group is named as the conductors. The second group is named as insulator, and the last group is denoted as the semiconductors. This semiconductor is a very important parameter for our subject. So, what is conductors? Conductors are basically those type of materials which can carry currents at all conditions generally. That means conductors can carry the currents at all conditions, because in conductors there will be available amount of free electrons, which will help them to carry the currents, like different types of material, different types of metals. Different types of metal will be the conductors. Secondly, if we talk about the insulator, insulators are such materials which can't conduct the current at any conditions, because inside the insulator all the electrons are tightly bounded by their nucleus. That's why there will be no available amount of free electrons. That's why they cannot conduct the currents. But the semiconductors are a very special type of materials which can conduct current only at some particular conditions. That means semiconductors is a special type of materials which can only carry the current if we provide suitable particular conditions. Under these particular conditions, they will behave that they can carry the current. That means at that particular conditions, semiconductors will behave as a conductor. But if we do not provide that particular condition, then the semiconductors cannot carry the current. That's why they will behave as an insulator. So we can say that semiconductor behaves in between the conductors and the insulators if we provide that particular conditions to the semiconductors, then the semiconductor will behave as a conductor, and if we do not provide the particular conditions, then they will not carry the currents, they will behave as an insulator. Like there are different types of semiconductors such as silicon, germanium, gallium arsenide, indium arsenide, indium, gallium arsenide, etc. So, this was the classification of materials depending on the electrical properties. Now let us see what will be the classification of the materials depending on the structural property. This is also important with respect to the electronic devices. So let us see the classification depending on the structural properties. So classification of materials depending on their structure. Now, the materials will be classified depending on the structure. So, in this case, the materials can be classified into three groups. The first one is the crystalline materials. The second one is the amorphous material, and the third one is the polycrystalline material. So, what will be the discuss about the crystalline material? Crystalline materials are those materials in which the atoms inside the materials are arranged in a regular pattern. That means inside these materials, the atoms inside these materials will be arranged in a regular pattern, or we can say that in a periodic manner over a long range of distance, over a long range of length. or over a long range of atomic distance. Now, these crystalline materials can be metallic, can also be non-metallic. So we can divide the crystalline materials into two groups. There are some metallic materials which are crystalline. There are some non-metallic materials also. So there are also non-metallic materials also. Generally, the metallic materials which are in crystalline in nature are having the ionic bonding between the atoms. And the non-metallic materials which are crystalline in nature can further divide into three groups. The first one is those non-metallic materials which are having ionic bonding. The second one is the non-metallic materials which are having the covalent bonding, and the third one is the molecular crystal. Generally, this type of ionic bonding non-metallic crystal materials are such materials which are having ionic bonding, and non-metallic materials which are having covalent bonding are comes in this group. Covalent bonding non-metallic materials, and these are the molecular crystal materials. Now, these covalent bonding materials, that means such materials which are having covalent bonding, like semiconductors. Semiconductors falls in this group because inside the semiconductors, atoms are bonded with each other by covalent. We will discuss in further lectures what are the covalent bonding. Till now, we will only understand where the semiconductor belongs. Semiconductor belongs for non-metallic covalent bonding materials. Now let us see the amorphous materials. In the category 2, there is amorphous material. In the amorphous materials, the atoms are arranged in a irregular manner. That means there will be no regular arrangements of the atoms. There will be haphazard arrangements of the atoms inside the amorphous crystals, or we can say there will be no periodic arrangements of the atoms. And there are so many examples of such materials like chalk, glass, all are amorphous material because inside them the atoms are arranged in a irregular manner. Now let us go for the polycrystalline materials. Polycrystalline materials. In the polycrystalline materials, these type of materials are composed of many crystalline materials, many crystalline materials of different size and orientation. That means polycrystalline inside the polycrystalline material we can find different crystalline materials in a group, and each of the crystalline materials are of different sizes and different orientation directives. Now let us see the structural diagram or the schematic diagram of these three materials, that is crystalline materials, amorphous materials, and the polycrystalline materials. In the figure, we can see there are three figures. The figure A, this is figure B, and this is the figure number C. In the figure A, you can see that in this case the atoms are oriented inside the material in a regular manner. They are oriented in a regular manner or periodic manner. That's why this is a crystalline or crystal material, where these are the atoms. Similarly, in the side picture of figure A, you can see here the atoms are oriented in an irregular manner. There is no any regular arrangements of the atoms. Atoms are arranged randomly. They are taking positions randomly. There is no requisites arrangements. So we can say it is an amorphous material. So we can see the difference between the crystalline materials and the amorphous materials. Now, in the case of polycrystalline, we have already said that inside the polycrystalline material, we can find different crystalline materials of different size and different orientation direction. So this material is a polycrystalline material. So in this polycrystalline material, we can see, if you look closely, we can see different zones where the atoms are oriented in a regular manner. So if I distinguish the zone like this is one zone, this is another zone. In this way, we can distinguish different zones inside the polycrystalline materials. Inside every zone, you can see the atoms are oriented in different orientation directions. If I take the orientation directions in this manner, this zone, here the orientation direction is in this direction, here the orientation direction is in this direction. In this zone, the orientation direction is in this direction. Here the orientation direction can be in this direction. In this case, the orientation direction having this orientation here. Here the direction of orientation is having this direction. So we can denote the direction of atom orientation in this fashion, and we can see that in every zone the atoms are oriented in different directions and they are of different size. That's why every zone, every zones inside the polycrystalline materials are called the grain. So this is one number grain, this is two grain, this is the third grain. In this way we can denote the grain number. And the boundary between the two zones, or the boundary between the adjacent zones, are called the grain boundary. So this is the grain boundary. This is also the grain boundary. The boundary between. So these are called the grain boundary. So this was the schematic picture of the polycrystalline materials, and in the figure C we can see the real picture of a polycrystalline material. In this case you can see the zone very clearly. This is one zone, this one are the grain boundaries. These are the grain boundaries. So we can say the grain boundaries are this one, and the zones are, this is one zone, this is another one zone grain, this is another one grains. In this way we can distinguish the every grain, and the boundary between the grains are the grain boundary. So in this way we can classify the materials depending on their structures. And we have already seen that our interest material, semiconductors, semiconductor material is of our interest. We need to understand these semiconductor materials because we need to understand the electronic devices. So these semiconductor materials falls in the crystalline group. So we need to understand more about the crystalline groups of materials. So this is all about the classification of materials needed to understand the electronic devices. And last of all, do not forget to subscribe and like our channel to get more videos like this. Thank you.